All right, geometry students, I expect this lesson is going to be short and sweet. We are going to be talking about circles, something that's familiar to you. The thing is, what I need you to do in this lesson is really pay attention to the definition of a circle and think about it from the perspective of geometry. Just because you know what a circle is and you've been working with it for a long time doesn't mean you understand the theory behind what a circle is. And that's what this lesson is going to delve into a little bit. Circle theory. Okay, so what is a circle? I don't know if you've ever defined a circle quite this way before. It's a set of points on a plane that are a fixed distance away from a given center point. That's the definition of a circle. So it's not just some round shape, it's a set of points on a plane that are a fixed distance away from a given point. Think of drawing with a compass. You put the compass needle down in the center, and then you trace around a fixed distance away from that compass point to make a circle. That's how it's defined. The center of a circle is the point from which all points on the circle are the same distance. So that's how we would define what the center is. It's where your compass point would go if you were drawing a circle with a compass. The interior are all points inside the circle. Now keep in mind, the circle itself is the collection of points that are equidistant from the center. That means that the circle does not include its interior. It only includes the points around the actual circle, the points that are the same distance away from the center. A radius of a circle is a segment. It's any segment that has one endpoint at the radius, one endpoint at the center, it should be, and another endpoint, okay, at any point on the circle. So any segment that has one endpoint at the center and the other endpoint at a point on the circle is a radius. How many radii could you possibly draw in a circle? Well, there's an infinite number of radii that you can draw as long as it starts at the center and goes to the actual circle. The diameter is drawn by finding endpoints on the circle and then connecting them with a segment that passes through the center. If the segment doesn't pass through the center, you have something called a chord and not a diameter. The diameter is the maximum distance from one edge of the circle to another, from one side of the circle to another. But this is the actual definition, because I can't talk about an edge of a circle. What would the edge of the circle be? Usually when we talk about edges, we're talking about lines on the edge of a polygon. Instead, I'm talking about a segment that connects one part of the circle to another, and that segment passes through the center. And lastly, circumference is the perimeter, technically, of a circle, distance around it. We have an equation for circumference. You're probably familiar with this one. Circumference is 2 times pi times the radius. Now let's talk about pi for a second. Pi is a term that's defined by a circle. Pi is the ratio of a circle's circumference to the diameter, okay? And it's an irrational number. If we try to write out pi and find a terminating or repeating decimal, it never terminates, never repeats, just keeps going on forever and ever and ever. So that's what we're dealing with pi. We approximate pi by either using the numbers 3.14 or 22/7, but those are just approximations. You'll never get an actual perfect value for pi that's not rounded. And then the area of a circle is calculated simply by taking pi times the radius squared. So circumference is pi times the diameter, or pi times 2 times the radius, right? 2 times the radius is the diameter, 2 pi r. Area is pi r squared. Let's work some practice problems, see what this is all about. All right, so our first practice problem asks us to draw a circle P. When I say circle P, I mean that the center point of the circle is P. And then I'm going to include in my drawing a radius, a diameter, and the center labeled. Let's take a look at what this looks like. Here's circle P, okay? P is at the center. Here's a radius from the center to any point on the actual circle. And then the diameter is from one point on a circle to another point on a circle, a segment, and it has to pass through the center. So there we go. All right, letter B. Find the circumference of a circle with radius 0.5 meters. Use 3.14 for pi and round to the nearest hundredth of a meter. Well, hold on a second. This is going to be simply the equation pi 3.14 times the diameter. I know the radius is 0.5 meters, so this would be 2 times 0.5 gives me the diameter. 2 times 0.5 is just 1. So this answer should be 3.14 meters. Next, find the area of a circle with a radius 31 centimeters. Use 3.14 for pi and round to the nearest hundredth of a square meter. So here again, I'm going to use 3.14, but this time I'm going to multiply by something different. I'm going to multiply times the radius squared. So it's going to be times 31 squared. Punch that into a calculator to see what we get. If I multiply that out, I find that my answer is 3,017.54 centimeters squared. All right, the area of a circle with a diameter of 1 yard. Now you have to be careful with this, okay? We're being given the diameter. So we're using 3.14 for pi, rounded to the nearest hundredth of a square yard. I need 3.14 times the radius squared. But I know the diameter is 1. I'm going to use 0.5 for the radius. 3.14 times 0.5 squared is 0.79 square yards. That's a key though. If you're given the diameter and you need the radius, you need to remember to divide the diameter by 2. The radius is always half the diameter. And lastly, a real-world problem. The lid to a sewer access opening is 35 inches in diameter. If you roll it in a straight line along the ground for 3 rotations, how much distance would it cover? Let's think about that for a second. So, if I roll it for 3 rotations, that means it's going to make 3 of its circumferences on the ground. So the way to do this one, first of all, also, I'm not using 3.14 for pi. It tells me to use 22/7 as an approximation for pi. Still an approximation because pi is irrational, but it's a little closer than using 3.14. So I'm going to do 22/7 times the, that's pi, times the diameter, 35. Why, that gives me the circumference. Okay, circumference is pi times the diameter, or pi times 2 times the radius, right? All right. Then I need to multiply this by 3 because we're rolling it across the ground 3 times. Now let's just look at this. 22/7 times 35. I can cancel this 37, or this 7 with the 35, and change 35 to just 5. Because 35 divided by 7 is 5. So this is going to be 22 times 5. Let's see, 22 times 5 is 110. Times 3 is 330. Let's see if that's what we got. Approximately 330 inches. All right, you'll be working some problems related to circles. This should be nothing new and nothing too difficult. I think you're going to be okay. Work the problem set 1 through 30.